Some people wonder, how did Einstein think? How do we physicists think? Most of it is when we're quiet, all by ourselves. We stare out the window and have blocks of equations just wandering in our head until these equations fit together, and then we get a sheet of paper and scribble.
It can be very frustrating at times, scribbling equations everywhere. The old cliche of scribbling on the back of the envelope often is true because that's sometimes all you have around.
He was always thinking in pictures, visualizing things. When his father gave him a compass, he would just sit up night after night watching the needle point northward. It would send chills down his spine.
Einstein once said, "I want to know God's thoughts in a mathematical way." Einstein wanted an equation, perhaps no more than 1 inch long, that would encapsulate all physical laws. The beauty, the majesty, the power of the universe into a single equation. That was his life's goal.
In 1900, Albert Einstein is a 21-year-old undergraduate at the Swiss Federal Polytechnic. That this young man will one day be synonymous with genius was something none of his professors would have predicted.
He would cut class. The professors thought he was a goof-off. As a consequence, Einstein couldn't get a single job after graduation. He even thought about switching fields and selling insurance. Can you imagine opening the door one day and there's Albert Einstein selling you life insurance? What a waste. Einstein thought he was such a loser. He wrote a letter to his family saying that it would be better if perhaps he was never born. Nobody was talking about the young Albert Einstein.
He worked as a substitute teacher in short jobs in various towns. Einstein's father tried to apply on behalf of Einstein for academic positions. And he wrote to a very famous professor and asked him whether he could use Einstein as a research assistant. But there were no positions available.
His father passes away, thinking that young Albert is a total disgrace to the family.
In 1902, the depressed and despondent young Albert moves to Bern, Switzerland's capital, and begins a career far from science.
One of his friends arranged for Einstein to get a job as a lowly patent clerk in the Swiss patent office.
In this office, on the 3rd floor, Einstein spends 6 days a week reviewing applications submitted by all kinds of inventors to the Swiss government.
Given a patent, you had all this information, and he had to strip it down to the essence, and that honed his skills as a physicist. He would very quickly dash off all the patents that he had to analyze.
He didn't find the work very strenuous. It was not so intellectually demanding.
And it would give him ample time to contemplate the universe.
He never would have been very good at a university kissing up to a senior professor. He was much better at a stool in the patent office, trying to daydream about what is it like to ride alongside a light beam.
From that job, he would launch a revolution which would change world history.
Einstein's idle daydreams will profoundly change the way the universe is understood. In 1905, in what's been called his miracle year, he publishes in his spare time 4 visionary papers, the first of which answers the age-old question, what is light?
The photoelectric effect. This paper, written by this total unknown, showed that light comes as a particle called the photon. We use that in television, we use that in lasers.
In another paper, the 26-year-old Einstein posits something we now take for granted, the existence of atoms.
People didn't believe in atoms in those days, but he proved that atoms can actually make small little dust particles move in a liquid. And he calculated the size of atoms.
These papers would have been a remarkable career for any physicist, but Einstein is far from finished.
He writes yet another paper with the famous equation E equals mc squared.
At the simplest level, this means energy can become matter, and matter can become energy. The tiniest speck of matter holds potentially huge amounts of energy. Unleashing it requires a nuclear reaction, the sort going on constantly in the night sky.
Ever since people began to look up in the heavens, they would say, what makes the stars shine? But it took Albert Einstein to answer the question. Mass, M, turns into E, energy. That is the engine that lights up the stars.
Today, E equals mc squared is Einstein's most famous equation. But another theory he publishes this same year is more important and more controversial: the special theory of relativity. When Einstein was a teenager, he enjoyed imagining what it would be like to ride a beam of light. Now, he returns to this daydream, and it changes his life.
In the spring of 1905, Einstein was riding on a bus, and he looked back at the famous clock tower that dominates Bern, Switzerland. And then he imagined, what happens if that bus were racing near the speed of light?
In his imagination, Einstein looks back at the clock tower, and what he sees is astonishing. As he reaches the speed of light, the hands of the clock appear frozen in time.
Einstein would later write, a storm broke in my mind. All of a sudden, everything kept gushing forward.
Einstein knows that back at the clock tower, time is passing normally. But on Einstein's light-speed bus, as he reaches the speed of light, the light from the clock can no longer catch up to him. The faster he races through space, the slower he moves through time. This insight sparks the birth of Einstein's special theory of relativity, which says that space and time are deeply connected. In fact, they are one and the same, a flexible fabric called space-time. Sitting alone on a city bus, Einstein believes he has glimpsed a secret of the universe.
For Einstein, space was this place where stuff was, and it didn't do anything. It had stuff in it. And so space combined with time to become space-time is a more dynamic understanding of this arena that everything takes place in. It's becoming more alive in a way. He's saying very, very outlandish and very, very strange things.
Rarely had anything so radical been submitted to Europe's most prestigious scientific journals.
He was a complete outsider to the physics of his day, as he was, being in Switzerland, being a patent clerk. And yet he was ambitious enough to think that he could challenge the whole of the established physics at the time.
You always hope that there will be total euphoria, that everybody will say this is a huge step forward in the subject. But that rarely happens.
Whatever one's concept of time, it passes slowly for Einstein at the patent office.
He submits papers to important scientific journals, the best scientific journals, and hopes for the best. And the best doesn't come for a while.
He was anxious. What was the reaction of the physics community to his great paper? Silence. Einstein got very depressed.
3, 4, 5 months must have felt like an eternity to him.
And then Einstein's papers fall into the hands of perhaps the one man who can fully understand him, Max Planck.
Max Planck is the greatest theoretical physicist in Europe.
Planck was the editor of the Annalen der Physik in Berlin.
The most important physics journal of the time.
Here was Max Planck reading this paper from this unknown physicist. And Max Planck says, there is something here.
Planck recognized immediately that this was an important paper from an important young scholar. The relativity paper was published in June 1905.
That volume, number 17, is now one of the most famous publications in the history of science. At the time, Einstein wasn't even a scientist.
He's still applying for jobs at colleges, high schools, always getting rejected.
We call it Einstein's miracle year. It is certainly not a time that he would describe himself as a miracle year. Miracles convey a sense of something happening easily.
I don't think that Planck knew that Einstein was a patent clerk of the third class. So he must have then become curious about who this unknown Albert Einstein in Bern was.
This unknown Einstein is in fact the father of a 1-year-old son and husband to a quiet and serious fellow student from the Swiss Polytechnic, Mileva Maric.
When he was at the Polytechnic in Zurich, he was quite a ladies' man. He would play his violin at ladies' luncheons and cocktail parties, so he knew quite a few young women in his day. But Mileva caught his eye.
Mileva is the only woman in the class.
Here was a physicist. He was smitten.
In a temporary detour from their shared scientific passions, Albert and Mileva are married in 1903. A year later, their first son, Hans Albert, is born. The Einstein family lives in this small 2-room apartment in the Swiss capital.
The rather limited circumstances in which they lived were not what he would have hoped for at this stage in his life.
Mileva had always wanted to be a great physicist, but she flunks her exams at the end of her terms at the Zurich Polytech. She becomes a sounding board on all the great miracle year papers of 1905, especially the special relativity paper. She helps type it up, she helps check the math, but she ends up being a housewife.
Einstein is trying to do his scientific work at the same time that he's working 6 days a week.
In 1907, Einstein agrees to write a new article explaining special relativity. But when he re-examines his theory, he finds it seriously limited.
It was called special relativity for a reason, and that was because it really only dealt with moving at constant speeds.
In other words, Einstein's special theory of relativity only applies to a special case, an object moving in one direction at a constant speed. But Einstein wants to understand the real world, and the real world doesn't work that way.
Einstein realized that his theory failed for accelerations. But in our universe, everything accelerates. On a bumpy road, jet airplanes, on a subway car, everything's accelerating. So there was a defect in special relativity.
On Einstein's imaginary journey, if his speed varies at all, his theory, his notion of how objects behave in time and space, falls apart.
His scientific mind wants it to apply to all cases.
Einstein knows that for his theory to work, it has to account for everything in the universe. And that includes the pervasive and invisible force that holds everything together.
Gravity. Gravity is everywhere. Gravity holds us to the floor. Gravity holds the sun together, the solar system together. Where was gravity in special relativity?
Einstein wants to expand his special theory of relativity into a general theory of relativity, a theory that will explain not just time, but also gravity. He realizes he will be fighting more than 2 centuries of scientific thought, and his hero, Sir Isaac Newton. It's 1907, and the 28-year-old Albert Einstein is still a patent office bureaucrat. It has been 2 years since he published his special theory of relativity, and the ambitious Einstein decides to advance an even more radical interpretation of the universe, a general theory of relativity. Doing this will require him to take on his scientific hero, Sir Isaac Newton.
In Einstein's time, Isaac Newton was God.
Newton was the founder of modern science. This is the actual first edition of Newton's Principia Mathematica of 1687. This priceless artifacts is the very, very famous book which became the foundation of universal physics for centuries, until Einstein upset the apple cart.
It has been almost 250 years since the apple fell from the legendary tree on Isaac Newton's estate, giving Newton the inspiration to formulate his law of gravity.
Newton said that if an object falls, it's because there's a mysterious force called gravity pulling it down. But you know, Isaac Newton himself was not satisfied by that. Objects move because they're pushed, not pulled. Objects move because they're pushed. So what is pushing this? Newton didn't know. So Newton simply threw his hands up and said, I don't know. So I'm going to invent something called gravitational pull. And Einstein said, no, this theory can't be right.
He was prepared to simply go, I really want to solve this problem. I want to really understand the whole universe.
Max Planck said to him, you can work on gravity if you want to, but there are two problems.
You're not going to be successful. The problem is too hard.
And if you do, no one will believe you.
It's an extremely difficult task. It's not clear where to begin or how to go about doing it at all. Ultimately, the thing that gives him that clue turns out to be his old faithful way of reasoning, the thought experiment.
It's what you and I would call daydreaming, but he gets to call them thought experiments because he's Einstein.
He's in his office at the patent office, looking out at the window, and he imagined a man working on a roof. And he begins to wonder what would happen if one of those men were to fall off the roof.
And then he had the happiest thought of his life, the inspiration of the ages.
He had a vision. The man will not actually be feeling his own weight.
He would be weightless. And then he imagined, if you're in an elevator and somebody cuts the cord, what happens to you? You fall. But the elevator falls at the same rate you do, so you are weightless inside the elevator. So then Einstein got it.
It's as though gravity's been switched off. What's really going on?
There is no such thing as gravitational pull. The Earth has curved the space around me, and space is pushing me into this chair. Space itself can be curved.
That's crazy sounding.
Space is adjustable.
It's actually malleable. Space and time are malleable.
It's this flexible thing that can be twisted.
You bring an object into space, and it distorts the space around it.
Why does the Earth go around the sun? Most people would say, well, the sun's gravity is yanking the Earth toward the sun in a circle. Wrong. The Earth is going around the sun because the sun has warped the space around the Earth, and space is pushing the Earth toward the sun. He had a new theory of gravity, a new theory of the universe.
Einstein publishes his ideas about gravity. At the same time, his work on the atom brings him increased attention. As a result, in 1911, he's offered a position as a full-time scientist at the University of Zurich. The 32-year-old patent clerk finally leaves Bern to become, for the first time, Professor Albert Einstein.
People start realizing that those miracle year papers of 1905 are probably right. And he starts getting invited to the Solvay conferences, which are the gatherings of the greatest physicists in Europe.
Convened by the Belgian philanthropist Ernest Solvay, these conferences bring together the greatest scientific minds in Europe, and Albert Einstein is among them. In fact, he's the youngest professor there.
He made an impression. He was friendly, he was funny, and he was smart, really smart, and people saw that.
That was also a moment when Mileva must have perceived that she was still part of this small Bern world, whereas Einstein had become part of a bigger world.
She writes these plaintive letters saying, tell me about it. I wish I were there. I would love to meet these great scientists. It was always my dream to meet these great scientists.
She became jealous of not only the other physicists, but of physics itself.
Einstein's lectures become the talk of scientific Europe, and he's invited to speak in Berlin, capital of the country in which he was born.
Berlin at the time was the most vibrant city in Central Europe.
Einstein hadn't been in Germany since he left at age 15 to avoid the draft. He renounced his German citizenship the next year.
While Einstein was in Berlin, mainly to visit colleagues, he was also invited by a cousin.
A first cousin named Elsa Einstein. They had known each other as kids, but Einstein had lost track of her.
Living on her own, had divorced, she had 2 daughters.
She's just the opposite of Mileva. She's not a scientist, she's not an intellectual, but she loves making big old dinners and taking care of Einstein.
They liked each other's company, taking long walks, looking at the boats, and he must have been fascinated by her. Einstein returns to Zurich. They exchange fiery love letters.
And at one point, it becomes so strong that Einstein says, please don't write me anymore. This isn't going to work.
He must have felt that this was an overcomplex situation, even for an Albert Einstein.
If the mysteries of the heart elude Einstein, the mysteries of the universe trouble him even more.
The curvature of space and warping of space-time, and you scratch your head.
He has now been struggling for 4 years to more fully develop his general theory of relativity.
His theory of relativity is so complicated that very few people can understand it.
Somebody's got to test it.
It's not a testable hypothesis. It's not science. It's science fiction.
Einstein knows he's on the right track towards solving his theory. Now he must find a way to prove it. It's 1911. For 4 frustrating years, Einstein has struggled to perfect his general theory of relativity. His theory won't be accepted until he can demonstrate this radical concept. Suddenly, he is struck by an idea. If he can shine a beam of light through an area where space is curved, then according to his theory, the beam of light will actually appear to bend.
Light only knows straight lines. What's bent is space.
What could have enough gravity to bend light so much? Well, what about the sun?
300,000 times more massive than the Earth, the sun is the perfect object for Einstein's experiment. But how can anyone shine a beam of light around the sun?
He says light from a distant star, as it passes right next to the sun, and the sun's gravitational field will be bent.
Because space is bent around the sun.
But even if Einstein is right, he'll never be able to see it happen because the sun is just too bright. Except,
when is the sun covered so that we can see what's around it without being blinded by the light? That only occurs during a total solar eclipse.
Here's the sun, and it's blocked by the moon, and suddenly all the stars come out. He figured if you have the sun here, and there's stars way back here, and the light's coming in toward you, it will bend slightly. So to your eye, you think that the stars had gone out like that.
Light going around the sun. That's something that even his mother could understand.
Nobody actually was willing to say without doubt, this is the truth, until somebody can prove it by taking a picture.
So who do you turn to? You turn to the astronomers, the astrophysicists. Our laboratory is the entire universe.
by 1912, Einstein believes he is finally on the verge of proving his long percolating and provocative theory.
He publishes this revolutionary prediction and puts the call out to the astronomy world. Go out and measure. He said, go to an eclipse and do this observation. Nothing happened.
He actually wrote to
well-known astronomers trying to interest them in doing a test, and was a little discouraged, I think, because he discovered, as people often do, that astronomers are busy people with many things to do and don't necessarily drop everything at the drop of a hat, even for Einstein.
It's a frustrating and bitter setback for Einstein. But then, at the Berlin Observatory, a young assistant answers the call. He's an impassioned and brazen young man who's willing to go, quite literally, to the ends of the earth for Einstein. His name is Erwin Finley Freundlich.
Freundlich was in his early 20s. He wanted to make a name for himself. He got a sense that here is my chance. This is new stuff, it's important stuff, and I could be part of it.
I've seen the letter that goes in the other direction from Einstein to Freundlich, and it's all filled with this excitement. You astronomers can do great help to me by finding proof of the relativity theory. And that's Einstein, the human being, who is trying to get somebody to do things for him because he needs him.
He finds out from Freundlich that he's getting married to his girlfriend, Katja. And they're going to honeymoon in the Alps. So Einstein says, come to Zurich and let's meet.
Freundlich is on his honeymoon with his bride, and he goes to meet Einstein.
He's looking for him out the window, and there he is. There's Einstein. He can recognize him because he's wearing this straw hat, and he's standing out like a sore thumb. And this is the famous Einstein that he's corresponding with this prediction and this great opportunity. And he's going to get to meet him. So he gets off the train and he shakes his hand and they're all animated. And before they can talk, they whisk the couple off the train and they go to Frauenfeld nearby. It's a suburb.
To their surprise, the newlyweds are spending their honeymoon in an auditorium, listening to Einstein speak.
And in the middle of the lecture, Einstein says, we need this eclipse test, and the man who's going to decide is sitting in the audience. His name's Erwin Freundlich, and there he is, and everyone looks, and Freundlich has to stand up and be recognized. And so Freundlich was thrilled, you know, this recognition at this great meeting. On the way back to Zurich, Einstein engages Freundlich in an intense discussion about gravitation while the new fiancée, Katja, just looks at the scenery.
They start hatching up that plan of going to a total solar eclipse.
The problem with the total solar eclipse, of course, is that it's only visible over a small area of the Earth because the shadow of the moon is actually only a few miles wide.
They get these tables and they realize that the next total solar eclipse will occur in the Crimea, which is in Russian territory, on the 21st of August, 1914.
Freundlich goes to his boss, says, look, let's go to Russia. I'm collaborating with Einstein. Will you put the money up? And he says, no way. He just refuses. Einstein is absolutely furious.
Reaching beyond the European scientific establishment, Freundlich writes to the director of the Lick Observatory near San Jose, California, a rugged outpost of American astronomy.
It was a community living on the mountain. They all had their families, their wives were there, their kids were there. They were depending on each other for survival. For many years, it had the largest refracting telescope in the world.
But most importantly, it has William Wallace Campbell, a pioneer of eclipse photography.
In the 19th century, eclipses used to be attended by astronomers who just did visual observations. I saw this, I saw that. They would draw diagrams, and if people disagreed, it was one guy's word over another. Photography meant you can actually capture what was happening and do precise measurements. Campbell pioneered that technique in the early 20th century. Freundlich writes a personal letter to Campbell. He says, there's going to be an eclipse in 1914. Why don't you come to Russia and let's do this? So there's this wonderful correspondence between Campbell and Freundlich, the senior doyen of California astronomy and this little pipsqueak of an assistant in Berlin who's doing this against the will of his boss.
They will be the first to either confirm or to discredit Einstein's new theory of gravity.
This was an important observation. Campbell had a fever in him. He saw fantastic opportunities for Lick Observatory and for America. And he says, I'm going to get this sucker. This is a tough problem, and I'm going to be the one to crack it.
Meanwhile, opportunity is knocking on Einstein's door. His original mentor, Max Planck, is asked by the King of Germany, Kaiser Wilhelm II, to recruit the best scientists for a new institution in Berlin. Planck recommends the young man he considers his own discovery, Albert Einstein.
And they said, if we bring Einstein here, people will look at this and say, Berlin is where the action is. It's worth whatever it takes to get him here.
On July 11th, 1913, two men arrive at the Zurich train station, Max Planck and Walter Nernst, a renowned German chemist. They are hoping that a personal appeal will persuade the rebellious young scientist to return to his German homeland.
Two men, middle-aged guys in dark clothes, get off the train, and they go find Einstein.
They're so different. Max Planck is very proper Prussian, always very well-dressed and well-groomed, wearing the monocle, talking in very formal tones. And there's Einstein, who's refusing, even back then, to comb his hair and dressed in, you know, sort of old coats and however he feels like it, already starting not to wear socks. They make a great offer to him. He'll be a professor at the University of Berlin. He'll be a member of the Prussian Academy. He won't really have to teach classes. He'll have all of the research help he needs.
It was Max Planck. It was Nernst. It was the Prussian Academy of Sciences. It was the entire world of physics that had said no, bearing down and saying, we want you. Einstein did not answer the offer.
Einstein says, why don't you just go take a trip for the rest of the afternoon up the mountain?
I said, I'll meet you at the train station when you come back. I'll be carrying a bunch of flowers. And if the flowers are red, I'm coming to Germany. And if flowers are white, sorry, no go. Thanks for coming. I've made the argument that Einstein delayed his answer to this question, in part because he sort of wanted to live with the pleasure of being so deeply sought after. But it's certainly true that this was not simply a snap decision.
As he often does when he has a difficult problem to solve, Einstein takes a long walk.
Zurich was comfortable. There was lots to love there. You don't just sort of walk away from that.
His wife really wants to stay in Zurich. On the other hand, they've offered him the greatest job imaginable. There was one other thing enticing Einstein to Berlin.
At some point, he received a birthday card. It was Elsa writing him a postcard. This must have exploded on him as, you know, reawakening all these emotions.
Planck and Nernst come back. They're at the train station. Einstein is there. It was a dramatic moment. It was a self-consciously dramatic moment. There would have been a little dramatic flair there. He's holding his flowers, and they look, and the flower is red. Einstein says, gentlemen, I'll go to Germany. I'm going to become one of you.
By April 1914, Einstein's world is looking brighter. The solar eclipse needed to help prove Einstein's long-gestating general theory of relativity is only 4 months away, and Einstein is on his way to Berlin to join the Kaiser Wilhelm Institute, an elite group of scientists working under Fritz Haber, the institute's director.
Fritz Haber was one of the greatest chemists of the 20th century. He developed a process that could be used in producing an artificial fertilizer with the help of which millions could be fed. And he was a hero.
Haber and his family host Einstein's wife, Mileva Maric, while she looks for an apartment for herself, Albert, and their 2 children. Haber observes that resettling in Berlin seems to be unsettling relations between Einstein and his wife.
Mileva always was a brooding and somewhat despondent woman. And in Berlin, it gets much worse. He's dallying with his cousin, Elsa. Einstein is a very brutally honest guy, so every now and then he apparently would tell Mileva about Elsa. And they start fighting with each other.
Not surprisingly, the man who approaches the universe in a unique way has a rather unconventional approach to married life.
Einstein gives Mileva an ultimatum. If you want to stay married to me, you have to do the following things. It's a contract. It says you have to bring me my meals in my room. You have to speak to me only when I want to have conversation. You're not to expect intimacies from me. More power to her. She doesn't sign this contract. She decides, no, I'm not going to go for that.
She goes and stays again with Haber and his wife Clara. In that time, Haber is sort of a go-between and is negotiating.
He's trying to hold them together. He's the one who keeps seeing if maybe they can come to an accommodation. They both respect him.
But Haber's best efforts to save the Einsteins' marriage are a failure.
The decision to split is finally irrevocable, and Einstein says it's not going to happen.
Lacking enough money to support two households, Einstein makes Mileva a brazenly self-confident proposition.
He offers her a deal. He says to her, one of these days, one of my papers will win the Nobel Prize. If you give me a divorce, I'll give you the money. Now, this is an amazing sum of money. She could end up very wealthy, and she could move back to Zurich with the kids. He is sure he's going to get a Nobel Prize. Mileva's not quite sure. She's a scientist. She calculates the odds. She consults with Fritz Haber. She decides to take the bet. Mileva takes the two young boys, and Einstein accompanies her, along with Fritz Haber.
Einstein has to go to the train station, say goodbye to his boys.
And he starts crying. Haber's never seen him cry before.
This was a really quite devastating moment for him, and Haber was the man he was with, sort of holding him up through this moment.
Einstein has staked his children's future on winning the Nobel Prize, by no means a sure bet. He is dependent on Erwin Freundlich and William Campbell to bring him photos of the total solar eclipse so he can see how the stars seem to move. Shortly before saying goodbye to Mileva and the boys, Einstein has another farewell at the Berlin train station.
There is Freundlich with his two buddies about to leave Berlin. Einstein is there. He's very, very anxious.
Freundlich and two of his colleagues are lugging 4 astronomical cameras and cumbersome equipment on a long and treacherous journey.
They're going to take a train and go all the way to the Crimea in Russian territory.
Freundlich and Campbell hope to maximize their chances of good weather and good eclipse photographs by camping in different sites. Freundlich's party sets up in southeastern Crimea. Campbell locates near Kiev. They are both determined, despite the frightening and spreading rumors of a world war. Then the worst happens. On June 28, 1914, the Archduke Franz Ferdinand of Austria is assassinated. The German Kaiser declares war on Russia, and Einstein's eclipse expeditions are suddenly in jeopardy.
Einstein is really worried.
Einstein has no way to warn them.
Didn't know what was going to happen.
And then, deep in the Crimean forest, the war comes to Freundlich's camp.
Freundlich suddenly sees some uniformed Russian officers coming to his camp and asking him for his papers. Heart starts going beep, beep, beep.
Russians come over to see what they're doing and realize these are Germans with a telescope.
And they start tearing down his equipment. Get off my equipment. I have to observe an eclipse. These are our possessions now. Your country declared war on us. You have nothing to say.
They arrest them immediately. There's no questions asked, and they are considered spies.
Herr Freundlich, you are now a prisoner of war. What? Campbell, an American, is neutral. And the Russians allowed them to continue to observe the eclipse. They had come all this way, spent all this money, survived the fact that war broke out, and clouds ruined their plans. Total failure.
Not only does Campbell fail to get his photograph, but he is forced to abandon his state-of-the-art equipment. Because he is an American, Campbell is not arrested, but he leaves for home a defeated man.
Campbell says one wants to come home by the back door and see nobody.
Einstein in Berlin is shattered.
The expeditions are failures. Freundlich and his team spend several months as prisoners of war in Russia. For Einstein, it is a disaster. Proof of his most revolutionary theory, general relativity, is slipping between his fingers. The outbreak of World War I leaves Einstein's Russian eclipse expedition in shambles and threatens to further obscure the long-sought proof of the relativity theory on which Einstein has labored for years.
The war killed communication between scientists. The open exchange of ideas was gone overnight.
Ties were cut.
Once the United States joins the war, astronomer William Campbell sees things differently.
Campbell dedicated himself to the eclipse problem, independently of his former colleague from Germany, who he now viewed as the enemy.
In Berlin, the whole atmosphere changed. When Einstein looked out of his window, he would see a lot of patriotism. In his eyes, a whole nation went crazy.
All of Einstein's expectations of the kind of city he was going to live in disappear. They're gone.
Hundreds of thousands of German young men marched enthusiastically.
His best colleagues, Planck and Haber, were enthusiastic about the war.
His close friend Fritz Haber, like Einstein, was born German and Jewish.
Fritz Haber converted to Christianity, and he tried to assimilate as much as possible. One of his great moments of pride when he actually received a commission in the German army. Really almost unheard of award for a converted Jew. Einstein saw this as ridiculous. Haber said, I'm a chemist. I understand the chemistry of the chlorine atom very well. I know that chlorine gas is poisonous. Can I turn this into a useful weapon? Haber felt he could construct a devastating enough weapon that it would end the war quickly, thus a humane outcome.
The institute Haber directs is turned into testing gas to be deployed on the Western Front. Einstein has an office in Haber's institute.
Einstein was disgusted by the eagerness with which Haber, first amongst his colleagues, but many of his colleagues, went looking for ways to kill people and kill them more effectively.
Haber was one of the first to develop terrible weapons out of the potential of science.
Early in the war, Haber's new mystery weapon, poison gas, is tested on a Belgian battlefield.
Haber was there and said, release the weapon.